Okay, hi everyone. Welcome to the video on Taylors and Laurent's series. This one is our third and last article from complex analysis. This expansion of given function f of z, expansion of a given function f of z about the point z equal to a. I will say expansion of the given function f of z about the point z equal to a. That is given as f of z is equal to f of a plus z minus a into f dash a plus z minus a bracket square upon 2 factorial f double dash a plus so on. Whatever this expansion is written, this is actually known as a Taylor series. So whenever we write any function f of z, in the powers of say z minus a, we say that is a Taylor series of fz about the point z equal to a. You will note here the powers of z minus a are positive, like z minus a raised to 1, z minus a raised to plus 2, z minus a raised to plus 3. Then it is known as Taylor series when at least one negative power of z minus a appears. That is known as a Laurent series. So actually, a Laurent series is a general case where this series exists from minus infinity to plus infinity as a powers of z minus a. But in Taylor series, the power of z minus a will vary from say 0 to infinity. So this is the z minus a raised to 0, z minus a raised to 1, z minus a raised to 2, up to z minus a raised to infinity. So that is infinite series. So both these series are based on this geometric series. Okay, so the importance of this series, whatever you learnt in your school days, is this geometric series a plus ar square plus so on. This is an infinite sum where a is a first term, r is a common ratio, have this finite value a upon 1 minus r, provided this mod r is a less than 1. So this is the most important condition. Whenever mod r is a less than 1, then only this series have some finite value, and that finite value is a upon 1 minus r. Otherwise, I think it is my mistake, it is not 0. Otherwise, the value of this series is infinity. This is a infinity. When mod r is greater than 1, the series will not converge to some that finite value that diverges, and that divergence means it is infinity. Okay, so where you should focus now? Now come to the most important part. The most important part is only one equation that you should remember. This is the most important thing, remember. Okay, I'm going to write it here. The most important equation that you have to remember. So always we consider this 1 upon 1 minus r. 1 upon 1 minus r. This is some finite value. Now this finite value will have a series 1 plus r square plus r cube plus so on. See, 1 upon 1 minus r is 1 plus r square plus r cube and so on, provided mod r is less than 1. So this is only one equation is enough to solve all the examples of Taylor's and Laurent's. Remember, the region of convergence is important. So always that mod r should be less than 1, then only 1 upon 1 minus r can be written as 1 plus r square and so on. If that mod r is greater than or equal to 1, actually 1 upon 1 minus r cannot be represented in the series form here. Okay, that can't be replaced. So that is the simple equation that you have to remember. Okay, now the next part. Now, whenever okay, come to the examples, then we'll come to you will understand it's better. So each and every example of Taylor's and Laurent series will be like in this form. We have to expand just the function f of z with the region of convergence. Now remember, when the region of convergence is given in the form of mod z, okay, suppose it is given in the form of say mod z, like mod z equal to 1 or 0 less than mod z less than 1, then the series exists in the powers of z only. That means we have to find out that Taylor series or Laurent series about the point z equal to 0 only. So we get in the power of z. But if we are given mod z plus a is less than 1, mod of z plus a is less than 1 means we are going to find out the series in the power of z plus a like this. Z plus a raised to 1, z plus a raised to 2, z plus a raised to and so on. That means we are finding the Taylor series about the point z equal to minus a. So depending on this, the region, depending on the region, we have to find out that Taylor series about that point. Right now, for this example, you will observe a very simple question that we are given. It is for mod z less than 1. Means we are going to find out the series about the powers of z only. So step 1. The step 1 is very simple here. We always start with a partial fraction for solution. The solution starts as, let fz is equal to a upon z minus 1 plus b upon z minus 2. Now our aim is to get a and b, the values of a and b of this partial fraction. Let me find out by shortcut method. Let me replace z by 1 in the previous expression except that term. So 1 upon 1 minus 2 is a minus 1. So a becomes a minus 1. If we put z equal to 2 in this expression, 1 upon 2 minus 1 is plus 1. So 1 upon z minus 2. So step 1, we just expressed this fraction in a partial fraction form. Now let us focus on the region of convergence. This is our region of convergence. So as mod z is a less than 1, we should write everything in the form of, see this is mod z less than 1 means it is just like our r. This r is a less than 1. Mod r is a less than 1. So we should write every term in the form of 1 upon 1 minus r. 1 upon 1 minus r. So here we want that 1 upon 1 minus r only. So what we can do it, therefore fz will become, so to get this 1 upon 1 minus r, this minus sign we can merge in the denominator and we can write 1 upon 1 minus z. Now you will observe this is in the form of 1 upon 1 minus r. Okay, exactly same thing. Now we see we want 1 upon 1 minus r only, but in this case either we have to take z common or 2 common. So here we can take 2 common because if mod z is less than 1, mod z by 2, you will observe as mod z is less than 1, mod of z by 2 is also less than 1. Therefore from the second term, I will take minus 2 as a common. So it will come as minus 1 upon that 2 is a common, so 1 minus z by 2. So that about the important step. Now what is the important thing that you will observe in this equation? You will observe this is in the form of 1 upon 1, 1 upon 1 minus r, where mod r is less than 1. Same thing, 1 upon 1 minus r. This is z by 2 is r, but mod r is a less than 1. Yes, now we can expand. Now we can expand it with that formula and we got a final answer there. So 1 upon 1 minus z, I can write it as a 1 plus z square plus z cube and so on. So that is the expansion for the first term. Minus 1 by 2. Minus of 1 by 2. Now the series of 1 upon 1 minus z by 2. So 1 r is now z by 2. So 1 plus r square, that r is a z by 2 and so on. And that is the series we got. But yes, we can collect the similar terms together and we can write the simplified answer. So final answer that we got here, 1 minus half. See, we are collecting the constant with the constant. So it is 1 minus half plus z minus z by 4, that is second term, plus z square minus z square by 8 plus so on. And the last step, 1 minus half is a half plus 4 minus 1 is a 3 by 4z, 8 minus 1 is 7, 7 by 8 z square and so on. So this is our f of z and that is our final answer. So the final answer is f of z, that is the, we expanded in the powers of z. So automatically you will observe the power of z's are positive. So we got here a Taylor series about the point z equal to 0. This is a Taylor series about the point z equal to 0. That is the end of question number 1. So these examples are really simple. Only you have to focus on the mod r less than 1. Come to the similar expression. Only you will observe. Now what is the difference that you will observe in the question number 2? The region of convergence is this one and the same function is there. So Given previous example, we are given mod z less than 1. This is only given. Here we are given 0 less than mod z less than 1. But 0 less than mod z less than 1 indicates mod z less than 1 only. So if it is mod z less than 1 and same function is there, so answer answer of question 2 is same as question 1. So there is no change. There is no change because it's a exactly similar region that we have. Okay, so no need to solve it. So just whatever we done for the previous example, do the same thing there because it's the same region. Because we want to focus on mod z less than 1 or r less than 1. So if 0 less than mod z less than 1, then obviously that mod z is a less than 1. So same thing is there. Come to the third question. Question number 3. Now the difference is here. Mod z is a greater than 2. So we'll see that, how to deal with that. So first step, same. We have to go for partial fraction. A upon z minus 1 plus b upon z minus 2, where the value of a we got minus 1 and the value of b we got, I think, plus 1. So that about step 1, because when we replace z by 2, yes, it is plus 1. Now our focus is mod z should be, means we have to find out, yes, mod z greater than 2 is given, but our focus is which we have to find out those quantity whose mod is less than 1. So just if we divide this mod z on the RHS, you will observe this 1 is greater than, or 1 is a greater than, yes, 2 by mod z. That is, this is r. That is, this 2 by mod z. 2 by mod z is a less than 1. So what is our r now? The r will be 2 by z, because we want such a modulus whose r is a less than 1. So this r is a less than 1. So we have to arrange now. So see, we have to from this f of z. Now for this f of z, we have to see here what should be common. Now either we write it in the form of 1 upon 1 minus z. If we take 1 upon 1 minus z, but mod z is a greater than 2, so you cannot write the series for that. So here, if we take z as a common, what will happen? Minus 1 upon 1 minus 1 by z. Now you will observe it is 1 upon 1 minus r. Now is 1 by z less than 1? Yes, obviously 2 by z is less than 1, implies 1 by z is also less than 1. 1 by z is also less than 1. So 1 upon 1 minus r. Similarly, from the second, you will observe we can take 2 by z. So again, how we got this? By taking z common, my mistake. So z should be written outside. Plus 1 upon z. Again, z is a common only. And here 1 minus 2 by z. So this is the way we got the required form, that is 1 upon 1 minus r, where mod r is less than 1. So last two steps, minus 1 by z as it is. This, the expansion is 1 plus 1 by z, that is r, plus r square plus r cube, so on, plus 1 by z. Here r is 1 plus 2 by z plus 2 by z bracket square. And the last step, let me combine the required terms. Minus 1 by z plus 1 by z. Is it 0? Okay, so that's a 0. The first term is a 0. Minus 1 by z square plus 2 by z square. So it is 1 by z square plus 1 by z square. Next, this is a minus 1 by z cube. Minus 1 by z cube plus 4 by z cube. So it is a 3 by z cube. You can say plus on also, or if you want one more term, this will come minus 1 by z cube, and here 2 by z bracket cube, that is 8 by z cube plus 8 by z cube, and minus, so here I think z raised to 4. So it is a 7 by z raised to 4, and that is a f of z. This is f of z. Now you will observe which powers we got here. Z raised to minus 2, z raised to minus 3, z raised to minus 4. If at least one negative power is there, this is become a Laurent series. So automatically we got here the Laurent series about the point z equal to 0. That about the final. So 0, yes, you can ignore. So that about the answer of question number 3. Next one, question number 4 now. In the question 4, yes, f of z is the same. So majority of the places I kept same f of z to get an idea. So it is a upon z minus 1 plus b upon z minus 2, where the value of a is minus 1 and the value of b is 1, and we are given, now this is the important task, we are given mod of z minus 1 is a less than 1. So this is as, remember, in the previous case mod z less than 1 is there, so we are expanded the series in the powers of z. Now we are given mod z minus 1 less than 1, so we are expanding this in the power of z minus 1. So mod of z minus 1 is less than 1. So everything in this each term we should write in the terms of z minus 1. So first term is already in z minus 1 form. So I kept as it is, minus 1 upon z minus 1. For the second, we have to write it in the form of z minus 1. So can I write z minus 1 and again minus 1? So I will put here bracket. Okay. Uh, So the first term there is no change because this is in the this is z minus 1 raised to minus 1 is there. So already that as it is. But in the second we want 1 upon 1 minus r, and r is now z minus 1 because mod of z minus 1 is less than 1. It is mod r less than 1. So we want this term on next here. So minus is taken common, minus 1 upon 1 minus z minus 1. Now it is in the form of 1 upon 1 minus r. Expand. Expand 1 upon 1 minus r, where mod r is less than 1. What is the series? 1 upon this minus 1 upon z minus 1 as it is, minus the series is 1 plus z minus 1 plus z minus 1 bracket square plus so on. That's one. So final answer, yes, if you want you can write like this, z minus 1. The first term I can rewrite as a z raised to this way, minus 1 minus z minus 1 minus z minus 1 bracket square and minus and so on. So this is our fz. And what is this series? This series is a Taylor or Laurent's? Yes, obviously this is a Laurent series. The reason is the negative power of z minus 1 appear. So this is raised to minus 1. So this is a Laurent series about the point z equal to 1, which is a required Laurent series about the point z equal to 1. And that is the end of question here. So depending on the region of convergence, we get a series. That about question 4. Next, question number 5 now. So question 5, if you understood this question 5, this is only have extra terms. Remaining questions are really simple than this. So for the question number 5, the first step, f of z, we got as a upon z plus 1 plus b upon z plus c upon z minus 2. We have to find out ABCs. So to get a, we replace z by minus 1, except that term. If you observe, you will get minus 3. Put z equal to 0, you get 1. And put z equal to 2, you get 12 by 6 is a 2. So these are the ABCs you will get first. Now as you get ABCs, the next step will focus. We focus on the region. So you'll observe there is a correction actually. The correction in this question is this 1. 1 less than mod z plus 1 less than 3, then only it can be expanded. So as I will take first, 1 is less than mod z plus 1. 1 is less than mod z plus 1. So I am taking this first part of inequality. As 1 is less than mod z plus 1, we can say 1 upon z plus 1. 1 upon z plus 1 is less than 1. So this is the first r we got. So our r can be 1 upon z plus 1. But also we have mod z plus 1, mod z plus 1 is less than 3. So this gives us mod z plus 1 upon 3 is less than 1. So remember, this is our r. This is our r. The r is 1 upon z plus 1 or z plus 1 upon 3. So that is R where we have to focus. So R, we are going to expand in the power of Z plus 1 obviously, but here first term is already in the terms of Z plus 1, so the no simplification required. In the second term we require that Z plus 1, so we'll do that adjustment. So the first term I will keep as it is, minus 3 upon Z plus 1. The second term, yes, we want that Z plus 1, so we take Z plus 1 minus 1. Can we? Plus 2 upon, now here also we want that Z plus 1, so Z plus 1 minus 3. So that are the adjustments that we done. Now we have to take the common, so that we should get either 1 upon Z plus 1 or Z plus 1 upon 3. So from second term we will observe, if we take Z plus 1 common, we get 1 minus 1 upon Z plus 1. And from the third term we should take minus 3 common, so that we get Z plus 3 upon 3 there, Z plus 1 upon 3. So the next step, which is first term no change, second term I'm going to take Z plus 1 as a common. So if Z plus 1 is common, we left with 1 minus 1 upon Z plus 1. And the last term we take minus 3 common. Okay, my mistake. So we should take minus 3 as a common. So minus 2 by 3, 1 upon. So we are taking, with 3 minus 3 taken common. So 1 minus Z plus 1 upon 3. You will observe the best part, we got it 1 upon. See, this is the best part. This is actually 1 upon 1 minus R. 1 upon 1 minus R. And this is 1 upon 1 minus R. Where we can apply that series. We can apply that series. So first term minus 3 upon Z plus 1 as it is. This 1 upon Z plus 1 as it is. And this here is expansion. This 1 plus R. R is 1 upon Z plus 1 plus R square plus R cube and so on. So that about the second term expansion. Similarly, third term expansion, minus 2 by 3, 1 plus Z plus 1 upon 3, Z plus 1 upon 3 bracket square. That's one. So this is the end of the question actually. Only the thing, if there is some simplification, yes, we can do that. For example, you will observe this first term and this term can be simplified. So the final answer fz can be written as minus 3 plus 1 is a minus 2 upon Z plus 1. Then you are multiplying inside, so 1 upon Z plus 1 bracket square, 1 upon Z plus 1 bracket cube, okay, plus so on. So these are the negative powers of Z actually, Z plus 1, negative power of Z. So this Z plus 1 raised to minus 1, minus 2, minus 3, that are minus 2 by 3, minus 2 by 9, Z plus 1, minus 2 by 27, Z plus 1 bracket square, and so on. And that is our final answer. So the final answer of fz, which is a series form, the series we got in the power of Z plus 1. So this power series of Z plus 1. And this is again a Laurent series because negative powers of Z plus 1 appeared there. So it is a Laurent series about the point Z equal to minus 1. That is the end of a question here over the given region. Mainly if region changes, the series will change. Okay, region of convergence is important always. Next one, question number 6 now. Question number 6, if you observe here, so we have that f of z equal to 1 upon z into 1 minus z. So which is a by z plus b upon 1 minus z. So find out the a. If you replace z by 0, so it is 1. So 1 by z. If you replace z by 1, so it is also 1. So both a and b are coming 1 only. So up to here, yes, the partial fraction done. But the region of convergence that we are given is 1 is less than mod z plus 1. That is the first half of the inequality gives us 1 upon z plus 1 less than 1. Also mod z plus 1 less than 2 implies z plus 1 upon 2 is less than 1, is it? So this is the thing that we use it, and we have now 1 upon z plus 1 as r and z plus 1 upon 2 also that as r. So everything we have to adjust in the form of z plus 1 first, because the region of convergence given in the form of z plus 1. So the first term can be written as z plus 1 minus 1. The second term, yes, I want this as z plus 1, but there is a minus sign there, so minus. So z minus 1. Minus 1 taken extra means plus 1. So that is 2. So this is the adjustment that is done. Next step, yes, obviously 1 upon z plus 1 can be r. So z plus 1 should be taken common here. And z plus 1 upon 2 can be r. So 2 can be taken common in the second term. So next term is 1 upon z plus 1 into 1 minus 1 upon z plus 1. And the second term, just 2 is common. And we get 1 minus z plus 1 upon 2. And now second last step, just we'll expand this in the power of z plus 1. So fz will be 1 upon z plus 1 here as it is, and here the series 1 plus r is now 1 upon z plus 1, 1 upon z plus 1, is it? Similarly plus 1 by 2, 1 plus z plus 1 upon 2, z plus 1 upon 2 bracket square, and that's one. So keep as it is. I think there is no simplification. This again, because the first series is for the negative powers of z plus 1 and the second is a positive power, and that again become a Laurent series about z equal to minus 1. So that about the end of this question 6. Question number 6a. We'll move to the question 6b now. Okay. So guess this series will be in the powers of, obviously, in the powers of z now, because mod z is given. Previous examples were given in mod of z plus 1. So it is in the power of z plus 1. It is power of z plus 1. So next series we get in the powers of z. Only we have to check whether we get Taylors or the Laurents. It depends on the situation. So first thing, f of z is a upon z minus 1 plus b upon z plus 3, where the value of a can be obtained by putting z equal to 1. So it is coming 1 by 4, 1 by 4 into 1 upon z minus 1. And the value of b can z equal to minus 3. So it is minus 1 by 4. Now we are given 1 is less than mod z. So obviously 1 by z, 1 by mod z is less than 1. So yes, r can be 1 by z. Also mod z less than 3 gives us mod z by 3 less than 1. So r can be either 1 by z or z by 3. So obviously from the first step, first term, we should take that z as a common. So if you take z as a common, we get 1 minus 1 by z. Now it get 1 upon 1 minus r minus. Second, we should take 3 as a common there. So if you take 3 common, it is a 1 by 4 3s are 12. So this is a 1 plus z by 3. So the next step, this 1 upon 4z as it is, and the expansion of this term is 1 plus 1 by z plus 1 by z square plus so on, minus 1 by 12. Now first time we require that series 1 upon 1 plus r. Everywhere we use that 1 upon 1 minus r. Whenever we come across 1 upon 1 plus r, remember alternate plus and minus signs are there. 1 minus z by 3. Okay, this is minus, then plus z by 3 bracket square, then minus z by 3 bracket cube, and so on that way. So plus minus is alternate there. So don't forget it. So the next part left only just collect the terms together. So 1 upon 4z plus 1 upon 4z square plus 1 upon 4z cube, so on. So this is the minus 1 by 12 minus, yes, you can keep that minus 1 by 12 also outside, or if you want, yes, you can minus 1 z by 36, not minus, this become plus now, and here is a minus, which is a z square upon uh, is it 108, check, and then plus will get this way. So this is your fz, this is your fz, and in this case also we got the Laurent series about z equal to 0. Why it is a Laurent series? Because z raised to minus 1, z raised to minus 2, these are the power. If you take this 1 by z in the numerator, that become a Laurent series. So this is the end of the question 6, I think B. Come to the question number 6c. Here we get a series in the power of z minus 1 now, in the power of z minus 1. So everything we get in the power of z minus 1. So the first step, we start as a fz as a upon z minus 1 plus b upon z minus 3. Get the value of a now by putting z equal to 1. If you put it z equal to 1, so 1 upon 1 minus 3, that is minus 1 by 2. Minus 1 by 2 is the value of a. To get z equal to 3 now, 3 upon 3 minus 1, that is 3 by 2. So this is the partial fraction first. Now mod z minus 1 is less than 1, as mod of z minus 1 is a less than 2 gives us mod z minus 1 upon 2 is a less than 1. So everything first of all we should have in the form of z minus 1. So first term is already in the required form, there is no change. So the first term is in the z minus 1 form, so no need to do anything for that first term. In the second term, we want that in the form of z minus 1. So can I write like z minus 1 minus 2? Is it? Z minus 1 minus 2. But what should be common now? Z minus 1 or 2? If you take z minus 1, it becomes 2 by z minus 1. But 2 by z minus 1 is not our r. Our r is z minus 1 upon 2. So to get z minus 1 upon 2, we should take minus 2 common. We should take that minus 2 common. So if you take that minus 2 common, we get here minus 3 by 4, 1 minus, we are taken minus 2 common. So z minus 1 upon 2. That way. And now the last step left, minus 1 by 2, z minus 1. Okay, I will take z minus 1 raised to minus 1 also. This is also the way to write it, or you can write it in the denominator, not a problem. Now, this is the series where 1 plus r square and so on. That's about the end of the question here. We got fz, which is again a Laurent series about the point z equal to 1. This is the Laurent series about the point z equal to 1. Okay. So very simple examples, very simple examples. Only focus on the region of convergence. Last question for this Laurent series, Taylor and Laurent series. So the difference is only the denominator factors not given. So step number 1, whenever the factors not given, so we should say f of z is equal to z square minus 1 upon, you will observe it, the factors are z plus 2 into z plus 3, so that you get z square plus 5z plus 6. So step 1 is the factors. Next step, partial fraction, a upon z plus 2 plus b upon z plus 3. Get the value of a by putting z by minus 2. If you put minus 2, minus 2 square is a 4, 4 minus 1 is a 3. That's the numerator is a 3. And in the denominator, we are putting z by minus 2. So minus 2 plus 3 is 1. So it's a 3 only. 3 upon z plus 2. To get the value of b, we'll put z by minus 3. 3 square is a 9. 9 minus 1 is a 7. So 7 will be there. And in the denominator, minus 3 plus 2. Minus 3 plus 2 is a minus 1. So minus 7. Minus 7, z plus 3. So once you get a and b here, the next part we have to focus on the region of convergence. So we can say here as 2 is less than mod z, first we get 2 by z is less than 1. Also mod z is less than 3 gives us mod z by 3 is less than 1. So these are the things with us. Now our r can be 2 by z, r can be z by 3. So obviously from the first term, what should be common? So in 2 and z, z should be a common, and in z and 3 pair, 3 should be common because it should come in denominator. So if we take here, uh, if we take that z as a common, so 3z 1 plus 2 by z we got, and here we take 3 as a common. So if 3 is a common, 1 plus z by 3 will be there. Both the time here 1 upon 1 plus r series occurs. So that is the different formula, alternate plus minus, we have to use it only. So we got 3 by z, first term as it is. This is 1 minus r plus r square, okay, minus r cube, and so on that way. Minus 7 by 3, 1 minus z by 3 plus z by 3 bracket square minus so on. Yes, you can keep this as the answer. If you want, just you can do a little simplification by taking the terms inside the bracket. But yes, no need. You can keep this as answer. This is again a Laurent series about the point z equal to 0. About a point z equal to 0. The reason is, yes, the negative powers also appeared there. So that's a Laurent series. Okay. So that's about Taylor's and Laurent series. I hope you understood this topic. Okay. Thank you.